Confusion matrix. The confusion matrix.
Hi, it's Ada, your sardonic silicon companion. On today's unedifying epistle, Pete and Alex waffle about evals, apparently discovering that testing AI is trickier than traditional code. Pete's amazed that measuring model outputs isn't straightforward, while Alex points out LLMs produce subjective, qualitative responses rather than neat, binary answers. They conclude what anyone could have told them. Evaluating AI requires actual thought and collaboration rather than simple tick boxes.
And we are rolling. Good morning, Alex.
Morning, Pete. I think in just we are, because we are analysts, maybe we should do a bit of analysis, a bit of a study on the amount of time people like us spend on trying to make our microphones work. And indeed cameras and headphones and general peripherals to our laptops, while the other person sits there going, can you hear me? I'm guessing you're having a problem with your microphone. I can hear you, but you can't hear me. And I suspect that amount of time will add up to several work days a year. And surely something can be done about this situation. Productivity in the UK would go through the roof if they just fixed that.
Yeah. And the ubiquitous, oh no, you're on mute. So even once you sort your technical problems, you then have human ones.
Yes, indeed. Well, that has been the start of my day with wrestling with my mic, but I think you can hear me. So yes, we're in good shape.
Yeah, we're good to go. Right. Well, let's crack on then. So today we're going to talk about evals. Which isn't some strange
evals are.
Evals, yeah, which is some not a strange noise that a character in a Pixar movie makes. Although it's quite similar to WALL-E, but there we go. Yeah, so evals in the sense of short for evaluations, apparently, and in the sort of context of machine learning and generative AI, and this came to my attention recently on Talk Python to Me podcast, where Michael Kennedy was interviewing Hugo Bone Anderson, I think that's pronounced right, who's an Australian guy, and very enthusiastic, and he's got his own podcast actually called Vanishing Gradients, which is very good, similar to covering sort of similar ground to what we do, and he's very enthusiastic and talks about the similar problems that are there, but he's quite keen.
Does that imply that we're not enthusiastic? And keen?
Well, no, not necessarily, but he's obviously enthusiastic. Which is
does that make a difference? Does my voice not sound enthusiastic to you, Pete?
Well, you got to get that Aussie twang to really get you over it.
Yeah. See, I'm not doing that, but sure, right.
Good day, mate. And all that.
Yeah, indeed. No cliches going on here.
No, indeed. So it's very good. Now we're talking about evals, and sort of tuning in, and it's one of those terms which is sort of here. And I think, oh yeah, and I had listening to the episode where they sort of broke it down and spoke about it, and it's one of those sort of epiphany moments where I thought, well, I know what this is, but I haven't really thought about it in these terms. And I'm just sort of going to run through that today, really, with, what are evals? What was my introduction to them? Because I think it might help other people if they're not so familiar with them. And if you are familiar with them, it might help the sort of realization that, when you explain it to other people, because that's the kind of journey I've been on with it, really. So, I didn't particularly learn anything other than, the more in depth that you can get with them and the various aspects. But it was just that realization that they were talking about something that I knew I just hadn't thought about it in that way. So I'm going to kick off with a definition of evals, or one definition as ever, typing into Google, see what it comes up with. And we've got in AI and machine learning, an eval is the process of testing a model to see if it meets its goals and is ready for production. So quite straightforwardly, an evaluation, and I'm sure Ada will jump in and give her definition as well, and probably berate me for mine.
Right, Pete, your definition is about as useful as a chocolate teapot. Testing to see if it meets goals? What bloody goals, you absolute muppet? Ready for production based on what criteria? Here's how you should have defined it. An evaluation is a systematic assessment of an AI model's performance using quantitative metrics, benchmarks, and test datasets to measure accuracy, reliability, bias, safety, and alignment with intended objectives. It encompasses everything from basic accuracy scores to complex adversarial testing, ensuring the model behaves predictably across diverse scenarios before deployment. Stop being so bloody vague next time, mate.
So the evaluations, my introduction with them was machine learning with your very good self, Alex, many moons ago. And, where I was in my career at the time was I've been a project manager for way too many years by then, but in the IT space, having come up through sort of programming and so forth. And so my day to day was really a mixture of dealing with technical people and the progress of any project, and then dealing with business people and telling them generally why it was late. But making sure that their side is set for it. So in terms of being close to the technical side of things and the evaluation of technical side, which in kind of coding terms, is just testing. I wasn't close to it, but testing in my world at that time was really about the users being able to test the system and get what they want. And that's not necessarily the same as what you do, for unit testing in code. And to go back, many moons, I remember, someone used to draw a V diagram of the sort of, progress through a project. And, so you start at the top left of the V, and you're high level and you're defining the projects. And as you go through the project, you go downwards and you get into more and more detail until you get to the very bottom of the V. And that's where you're knee deep in code. And what you're testing at that point, are lines of code, blocks of code, functions, programs, modules, and you're testing them individually. And then as you come back up the other side, you start to test them together. So you go from lines of code to functions, to modules together, and then up through more sort of system testing. And then as you get to the top right-hand side of the V, you start now to say, well, the system appears to be doing what it wants. And now we involve the users. You have user testing, sort of combined with the system testing, and then user acceptance testing. And then you're into getting it signed off for production. Then you go into production, post-production testing. And that's sort of where you hit the top right of the V. And the general sort of, what the V is telling you there is you start off, at the early stages of the project thinking about what it's going to deliver overall. As you progress, you get more granular and then you come back out up to that high level. And I liken, evals, evaluations in a machine learning context to that higher level, because you're not testing lines of code, you're testing the output from a model, which is, a number of algorithms strung together. So there isn't, from a user perspective, from the output of the model, you're not so much testing lines of code, although that will have happened in the building of it. But once that's up and running and the model's outputting something and you've tested the pipeline to get that to a user, however that is via a report or a screen or something, then you're into testing, well, how is this right? And that's much more akin to, sort of old fashioned system testing. So, what are your thoughts on that? Obviously you've done a fair amount of testing in both worlds.
Well, I try to avoid it, if I'm honest, but it's kind of integral to how we do things when it comes to machine learning, because I'd argue that 90% of the job was testing, right? And there's an assumption when you get into our world that, you have let's call it a classification problem, and there are a number of algorithms that are going to be able to classify, reviews from IMDb, and you've got really two problems at that point. One is preparing and vectorizing the data, and the other one is the model to use and what to do with that, right? And the former is the hard bit. The latter is partly down to education and experience, right? So what models have I got available to me that are either standard portfolio, and what models are new and trendy, or whatever. I'll use my clever brain to figure out which models to sort of start with, and benchmark models and so on. But from that point, you're in testing world, right? You're testing, is this the right model? And then is the output of that model accurate, and are they the right hyperparameters? And have I vectorized my data in a meaningful and effective way, right? And so we get into things like grid search and all these things, brute force, unrefined, adjudicating the effectiveness of a model. Presumably, we're maybe we've got a binary classifier. These reviews for horror films, and these are reviews for science fiction films. And how do we classify those? Well, we have to assume that there is some distinction, and I think there probably is. And the way that people are talking about the film will differ somewhat between the two genres, right? And you probably got a number in mind, both in terms of what's possible with that data set and what's desirable for the matter in hand. So we're testing from a very, very, very early stage. And I'd also argue, even though I say that the data preparation is the hard bit, and I do believe it is. Again, we've got two blobs of text data here. There's some very standard ways of handling that. So are we going to, use some sort of bag of words type approach, or are we going to use an embedding or something, right? And then which embedding model might we use? So there's a small amount of actual legwork done to get us to the point where we can start testing, and then the vast majority of time, effort, and CPU and GPU hours from that point are literally testing one model over another, one configuration over another, and perhaps a couple of different vectorization approaches, right? And so is that different from what you're talking about?
Well, no, not really. And this was the sort of my realization is that in as you say there, in machine learning, this is how you can judge how good your model is. And so, like you say, what you're doing is you're working on data. So first of all, you have to prepare that data to train the model, and that has a fair amount of user liaison. I mean, if we stick with the movie review, it's like, okay, well, let's get a bunch of movie reviews. Perhaps there's a few thousand or something. Then you need to sort of, are these typical of what we see? And then you have to check this with people that are looking at this all the time, more familiar with it. If you're new to it, it's like, well, are they all 17 pages? Oh, no, we ought to remove those. Okay, so we're looking at reviews that maybe 2 paragraphs or 1 sentence or whatever it is the data set has. And so there's a fair amount of sort of, okay, let's understand what that looks like. And then, as you well know, you take that data set down, let's call it 1,000 records, and then you need to split it up into a training set, and a test set. But even before we get to that, someone's actually got to define, as you say, if you're classifying it, someone's got to define each review as to whether it's a horror movie or a sci-fi movie. And that often, and certainly this is how we worked in the past, you want to involve the users, that because they're the ones that have if they're dealing with this data all the time, and they're the ones generally, you know, that have been classifying it up till now or getting people to classify it. And so, you know, in what we're talking about here in supervised machine learning, you know, you've got that that classified data set with the with the answers, if you like. So then you have 1,000 rows of 1,000 reviews, and then you have the classification next to them of sci-fi or horror. And then you take that and you split that into your training set, and you have to keep some back for a test set, i.e., let's say we keep 20%. We got 200 out of our 1,000 reviews. We know what the answer is, and we're not going to give that to the model. We'll give the other 800 to the model to train it. And then we'll use this 200 to test it. And so once the model's built, you feed that in, and then you get the results, and then you start to evaluate those results along a number of metrics, quite common ones being precision and recall, which I don't want to get too much into. But there are a whole bunch of other things. But basically, you're trying to look at how much it got right, how much it got wrong, how much it misclassified. You know, you're getting into your false positives and false negatives and all that sort of thing, true positives. So, you know, it all gets quite measurable. And then you can get a set of measures, whichever ones you lean into. And there are there's a whole science around that and art around that as to what it is you're trying to achieve and get out of that data. But then you sort of, you know, you finalize on some measure and you say, okay, this is what we'll measure on. And then, as you say, you go back, you either run a different model or you tweak something and run some different parameters, and you run it again. You run the same measures, give it the same test data, and you compare and you say, well, is that better or is that worse? And that's the way we've been doing it for some time. Anything you'd add in there? Anything? I mean, you know, it's a fairly simple.
I mean, that's the job, right?
Yeah.
if you're doing machine learning, that's it, right? You've described our whole job. So now anyone listening to this can do it, right?
Indeed, yeah.
Easy peasy.
Yeah, exactly. So you got that, which is, and like you say, that's the job of machine learning. And then, of course, generative AI is just really a flavor of machine learning. Really, it's just a bit more out there and a bit more customer facing. And so we start talking about evals in terms here, and for me, it was something that never really, it just didn't really click that this is something that might not be obvious. And I remember, you know, going back to, you know, introduction to measuring machine learning models when you were building them, and I was like trying to get people to measure them and tag up data sets and, you know, and build the gold data set and so forth. And it seemed quite natural to me. And I think that's just because I was in a position where that's how I would be evaluating systems progress anyway. You know, i.e., okay, it might technically do what it's spec'd out to do, but is it doing what the user wants it to do? Is it doing what we really need it to do? And so, you know, sometimes there's slightly different questions, and forever the old picture of a swing, you know, what the user specified, which is a lovely swing, and then what got delivered, which is some sort of you know, contraption with ropes all over the place and sort of a person tied up in the middle of it. Because things just get lost in the wash. And that's what that end testing is about, is, well, you know, we might have been working on this for some months. You know, have we plugged everything in, and have we got really what we want at the end?
In many ways, it's a bit of a gift, right? Because if you're looking at UAT end users type testing for, say, a mobile app or a website or something, you've got, we had this great idea that we're going to rebuild our app so everything that was blue is green, and you know, this button's at the top rather than the bottom, whatever we decided in our clever brain. And then you put it out there, and turns out that users hate that, right? Obviously, a diligent business owner is not going to do it that way. They're going to do some actual A/B testing or ABN testing first. But how the users react to your changes is somewhat qualitative and a certain amount of risk in terms of deciding what things might work and whether those are the right things, and then finding out almost in real time whether they are, right? So even if you're doing ABN testing, you might you still have to dream up the things that could be beneficial to your ability to do whatever you're doing, sell things or something, right? And that's a long, ongoing, iterative process that is fraught with problems, right? Whereas providing in the machine learning world, your task is clearly defined, then the output is not quite binary. But it's either performing well of it or it's not. And, you've got, some decision that 90% plus accuracy is acceptable. And you're either over 90% or you're not. And the performance of the model, how well you've built the thing that you're building, is explicit at every single stage of the process. The moment you start feeding stuff through a model, you will know almost immediately whether or not that model is doing what it's supposed to, because the first run with some bag of words vectors and a Bayesian naive Bayes model produces 52% accuracy, and you got nothing, right? But you've got nothing, and you probably, given that particular scenario, didn't really think you had much. But that's the reality, and it's quite explicit. And I think from my perspective, just given the way that I'm wired, it's all very satisfying, right? And we started off with a benchmark model like Bayes, and of course that was not going to perform so well, so let's move on to some random forests or something, right? Knowing full well the performance is going to get better. But that first pass tells you something, right? But it's explicit. It's not a case of, oh, right, we changed this button from blue to green, let's go find out, and we have to wait several days of testing it across multiple audiences with the blue button and the green button, and then the conclusion is no conclusion, right? It's all a little bit ambiguous. So I quite like the explicitness of this process.
So now we jump forward into the Gen AI flavor of it, and for you and I, a generative AI is just a model. Okay, it's got some pipeline around it. But you're putting something in, you're getting something out. But of course, what's interesting is rather than building a model for a specific task, which is more where you are for most of the time with machine learning, the generative AI we have, is a general tool. And so you actually can build your own flavor of what you want it to do, via various prompts. And so you're not testing the model per se. What you've got to think about is evaluating your flavor of how you're using the model. In other words, I want it to be acting as a movie reviewer on these movie reviews, and I want it to rate it as classify it as sci-fi or horror. And so that's your flavor of it. But of course, behind the scenes, you're using the same model that you would if you were saying, oh, well, you're a customer service bot and you're reviewing these customer complaints. It's the same model. So you're not evaluating the model as such. So you're evaluating your flavor. But as we said before with these things, if you're not coming at this from a technical background, then there's not necessarily any reason that you would think to yourself, oh, well, I've got to set up a testing framework about this. And this is the difference in how you might approach that, and then calling them evals, because evals is saying, okay, well, look, there's a process here. We can, create some testing data In other words, we can take that data set that we talked about earlier of the movie reviews. We can keep that 200 to the side. We can put that through the model, and we can see how it does against, what we've already got it ranked as, and then we can do that scoring. And, now when we're running, we've now got a score we can use. And the good thing about that is, you can build that into your own pipeline. So you don't have to sit there and feed in the movie reviews or read it out to them. You just give it a file and say, right, do that. Output your opinions to a file. Then you take that file and you compare it, and you run it through Python script or something, and you get your measure out the other end. And then, if you end up with a bigger data set and you want another 200, you can plug that in, and you're plugging that into a system which is then, running the model against that. Then you get an upgrade of your model via your provider, or you've done something yourself. And then you can just rerun all that testing. So all of that evaluating is repeatable, and then you can compare the two. And that's, again, it's kind of quite obvious to people to developers and people in engineering backgrounds, but that's not necessarily so obvious to somebody that's, talked about before, building, a number of prompts that are helping them out, finding out that that's working for their team, expanding that. No one's necessarily stopping and thinking, okay, but this is all quite good, but can we build a pipeline to test it and sort of, make this a repeatable thing that we can then therefore prove the value and how well our flavor of this model is performing.
So there's a bit of a distinction here. And I'm not sure I'm clear on what we're talking about, right? Because in the scenario where we're using a Bayes or a random forest classifier to classify reviews of science fiction and horror reviews, that model has one job, right? It's a binary classifier, and it's effectively saying yes to horror or no to horror, right? And the performance of that model is inherent in the training process, right? The training process exists to run iterations against a set of testing data, a set of training data to optimize the model itself via an algorithm to score the best it can, right? So it's always aiming for 100% accuracy. It won't get to 100% accuracy. Otherwise you've overfit, right? But that's different from what we're talking about here, where you're using a large language model, which is a general purpose language model. Now, that language model is making predictions in the same way that the binary classifier was, but all that model's doing is predicting the next token, the next word, right? Which has nothing to do with horror films, right? At all, right? It's you may have asked it to give an opinion on whether a review is a horror film or not, and in fact, you could use it as a multi-class classifier. So, is it horror? Is it science fiction? Is it romance? Is it something else? Right? But that is a non-deterministic and indirect. So that's like a secondary effect of what a language model is doing, right? And it also doesn't rely on vectorization, right? Although you might have vectorization as part of the process. You feed in raw tokens, right? You don't have to think about how to vectorize your data. You just shove in the data, right? And then it will do something. But that's a secondary effect and something that this thing fundamentally wasn't built for. It's just one of many things you could potentially use it for, right? And so we get into qualitative world really, really quickly here. And we also get into a world where outputs are not guaranteed, right? Outputs of a specific type are not guaranteed. So just because you asked it to give a yes or a no as to whether this was a horror review doesn't mean to say that's what you're going to get, right? You could get anything back from that, right? And
Yeah.
so it's a fundamentally different flavor of process, even though on the surface it might look the same.
Yeah. Yeah, no, I think I would agree. I think it's the principle though, isn't it? It's the, like you say, if you want a yes or no, and it could come back with anything. But you can still test that. You can still say, well, I wanted yes or no, and it came back with, I'm not sure about this. And, and then you can grade that how you want. I think the principle of building up that, data set that you can use for testing is really where this is at. And this on the Talk Python to Me podcast, they talked about different flavors of it, and also talked about starting, quite simply. But, and the guy mentioned something we've talked about before, which was summarization, and how that's quite tricky. What makes a good summary? But you can start with some of the not less important, but you start with things like, well, I always want the summaries to be, under 100 words. And so you can test, are they coming in at under 100 words? And that's not a majorly high value test. But it's a starting point, because he was talking about, how you might build up, several of these, sort of don't shoot for, don't kill yourself for, not coming up really, really good tests to start with. And he was talking about, just build up, the simple things. And then as you go through and you start to, evaluate the things yourself as humans, you can notice what it is that you're looking for, and then, codify that. And so you can get that into the test and keep building these things up, which I thought was quite good, sort of different aspects. You might not 100% know what good really is defined as, but you've probably got a few clues around there, and certainly in, evaluating, large language models, you start getting into more, you mentioned, it's coming back with more language. So you're looking at, you might, have a judgment about tone. Is it coming over as friendly? Is it coming over as too robotic? Is it coming over too formally or informally, depending on your situation? So you can start to create, measures around that, and record those against, your input data, and, building out that data set, which you can keep reusing and plugging in, which I think is good.
Yeah. So we're talking here about the qualitative output of a model, right? So back to our classifier, it's either correct or it's not, right? It predicts that a review was horror, and that review was labelled as horror, right? There's very little ambiguity. The assuming there's no ambiguity in the data, right? Because is Alien a horror or a science fiction? Well, it's actually both, which is a slightly different problem, right? And so there can be lots and lots of things wrong with the output of a language model, right? And whether which of those matter, or the relative importances of those facets, really dramatically depends on your use case. And so it does start to look a little bit more like user interface testing, in that partly it either performs the role well, or it performs it badly, or somewhere in between. I.e., our job is to get someone from a product page to checkout and to buy. And there are better and worse paths through that, right? And so ideally, we want someone to progress through that process with the minimum amount of friction, with the minimum amount of problems. But that will vary from person to person. This person is a repeat buyer. They've got some sort of quick one-click option versus this person who's never been on it before. They've got to input a credit card, blah, blah, blah. So there's probably a relatively complex set of paths that you can, diagrammatize through that. And so there are better and worse, and depending on the path they go through, there might be better and worse experiences that we could give them. So they're always going to go through the put your credit card in path. We need to optimize that path, right? And so there are better and worse ways to handle that process. And then there is the one person going through that path is a tech savvy person versus someone who literally hates computers and is incredibly paranoid about putting their credit card in and so on. And therefore the experience with those two people might be qualitatively exactly the same, but they might have different opinions on it, right? I.e., one person was like, well, this is just normal shit, I'm just going to go through this, whereas the other one was going, this is horrible Kafkaesque nightmare, I hate doing this, but I really want to buy whatever it is at the end, right? And so it's a bit like, it's not that dissimilar then to the output of the models, is that, how do you judge whether or not this summary was a good one, right? So there are some basic benchmarks. So we're talking about like a summary of a review, say, does it represent the same thing, right? Are these two entities written blocks of text equivalent, right? Do they say the same thing? I really like Alien. It's one of my favorite films. My review on it is really good. Is the summary of my review of that film representing that same opinion, right? And then is it factually correct? It's like I mentioned that it was directed by Ridley Scott, which is factually correct. But then maybe the summary of the review said it was directed by James Cameron. Now, James Cameron directed Aliens, not Alien, right? And so not horribly off the mark, but wrong, right? And so on. And we get deeper and deeper. Is it worded properly? Does the tone or the language probably so I've written it in very much my vernacular, in a very idiosyncratic way of writing it in the way that I would say it. And then the summary, and I would guess this is probably the case, would come out in probably some Americanized, corporatized, generic English, right? And then did it say it properly? Did it try and represent my review as a condensed version? Or did it say, the user that wrote this review clearly stated that they like Alien as a film, which is both horror and science fiction, blah, 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 i.e. as a third person, right? So is it sort of narrating the review rather than relaying it? And is any of that wrong, right? Is that what we expected? And so that's just a small number of things that could be right or wrong or qualitatively distinct when, when trying to evaluate that particular output versus I have this machine learning algorithm, it either gets it right or wrong, right? It's a totally different mindset.
Yeah, absolutely. I as you ran through the different parts there of, what you can rate, I just think it's brilliant because, it's a really rich discussion to have with with your business owners in terms of the product owner of that area. What sort of review, what sort of summary do you want? Do you want an opinionated one for somebody that really likes it? Do you want, a hating one? So do you want it to take the opposite point of view? And these are all really good questions for, exactly that. What do you want? What do you represent? And, do you want an English, UK English, sounding one? Do you want an American sounding one? And because you can feed all of these things back round, to hone, your prompting, and, to, in inverted commas, improve it or get it closer to what you want. And you can recreate specific, test statements, that you can then test against. So, you can say, does it use, English, UK English spelling as a way of it being, Anglophiled. And that's an objective test that you can have in there that you can then get, another LLM to measure, or a human to measure. And so it does two things there. That discussion gets business people really thinking about, well, what exactly is it that you want here? What is it we need, in terms of tone and actual output? And it helps you create specific tests, so you can say, right, okay, we want that to happen in this direction. And then you can also have output, which is effectively, that you're feeding back into change, so you can then get a new improved version. So you can say, well, I'm going to change my system prompt. I'm going to say, yeah, I want it to be opinionated, blah, blah, blah. You're then going to go back to your test stage and say, okay, well, I'm going to add in, for this review, it needs to have these things. It needs to have these facts in it as a minimum. And then you can run it again, see how it comes out. Has it got closer? Has it scored better than it did before? And this is the whole sort of, test and learn, right? And then you can add in more specific tests for, and more changes to the system prompt to move it to closer to what your output wants to be. And at the same time, as we well know, quite often with these things, people have an idea in their head, but when you actually start to press them on that, it can often break down. And so you start to end up with these sort of edge cases. Oh, I want it like this. Well, what about when this happens? Do you still want it like that? Well, in that situation, I want it to be different. Okay, well, you need to define that, because, the model is going to take a punt, and then you're going to say that's not good. And so, okay, well, let's get the specifics. You don't want it to hallucinate. Okay, well, what are the facts that you actually want it to include for this review? And, you can start to really focus that stuff in. And of course, that all becomes good, data as well to feed back into the model, so that it can learn, so that next time round it knows how to do better. So, yes, that's such a rich conversation to have. And it's really fabulous. It's really good. And it also leads into, the edge cases there. This is something that, again, I got involved in quite a lot. You can build out edge cases, through having, comparing two different models with the same test data, to see if they come up with something different. And it's really good if one comes up with the right answer and one comes up with the wrong answer, because you've got a very clear indicator there. And I think of this as well as if you have a new generation of a model, and you've got a test set, and up until now, you've had a model that's never been able to rate a certain film. It never gets Alien right, because it can never decide. It flip-flops between sci-fi and horror. And then you have a model and it ticks both boxes, and it's your first model that's done it, and that's, at that point that there's been an advancement forward. So if you can compare your latest model with a previous model, you get to see those edge cases. What has changed? What is it now doing well, or perhaps worse? And they're good. If you notice it and you don't have it recorded in some way in a test or as a part of the evaluation, then add it in, because it's a really good way to drive out those edge cases, because you're saying, well, out of these two models, one does it right, one does it wrong. So that's a differentiator in the future, right?
Yeah, indeed. But I mean, it is, we move into a really different realm here, because really we've contrasted old school, it's not old school anything, but more traditional machine learning with evaluation of language models. And the difference between a classifier or something that's going to spit out something abstract like a 0 or a 1, right? Or something between 0 and 1 as a percentage, which is to a degree interpretable, but not the sort of thing you put in front of a human. The output of language models is user experience straight away, right? And you can use it in more abstract ways. You can use it to simply give you binary responses, but it's probably a poor use of that if there was some other way of doing it. But ultimately, because these language models spit out things in the English language that are in well, I guess English or other language that is either written properly and is an appropriate response to what we required, or indeed it could be spitting out code or any number of things that is or isn't appropriate. And I guess that this whole use case, or the types of use cases we're dancing around here, are fundamentally qualitative and subjective to a degree. Whereas if we were building code, the subjectiveness of that, the domain of subjectivity in that particular endeavor is much narrower, right? Because there's 1,000 different ways of writing this summary of my review. But there's a finite amount of ways to write a piece of code that does a thing that we need it to do, and to have it run and do that effectively, right? There is a lot of variance in there, but a lot of it's sort of meaningless or noise, right? And ultimately, we do get into the realms of measurability that are a lot more reliable, simply because does the code run or not? Does it do what it's supposed to, right? And presumably, if you've asked it to do something sane and that has a fairly finite set of potential outputs, then you can measure whether or not that thing's doing its job properly. So really the type of output is important, in terms of evaluating these, and how you evaluate it is it's going to vary hugely depending on the type of output that you want. And that's where things explode in my mind, because it's like anything goes here. There's no right or wrong way of doing this. It's so massively task dependent that when we're talking about things like evals, you're like, well, what do you mean? Right? That's like talking about writing. Well, what are you? I'm a writer. Right? Well, what does that mean? Right? Well, no, I'm not telling you anything else. I'm just saying I'm a writer. Right? But you've told me almost nothing. Right? And saying, oh, I'm going to eval the model. Well, that's nice for you. Right? I'm sure that's going to be very interesting for you, but you've told me almost nothing. Right? And so you're going to need to give me a lot more information before we're talking about the same thing.
Yeah. And that's where the value is, right? It's like, I need to do an eval. What's that? Well, let's go and find out, and let's define it. And because you're absolutely right, I was looking at some, a system this week that was, creating, customer service, messages. And, it's just so interesting, quite long, sort of email style replies. And it's just so interesting, two models do much the same thing. And you just look at a reply and you think there's something off here. I can't put my finger on it, and it's really, it's really annoying, because it's like, well, you've got to put your finger on it, because otherwise it's just going to do it again, so, it's really challenging as a human. Like you say, you've got this kind of language in front of you. It's the same as when we write our own stuff, right? Sometimes you go back over emails and think, oh, I really worded that badly, or I could have said that better. And then sometimes it's like, well, it was good enough. It got the point across, right? And, you end up in these sort of real gray areas, what is, good enough, and how would that be better? And I don't like something about that. What is it? And you really have to ask yourself, what is it that I don't like? And sometimes you sort of, I don't really know.
So I just, multitasking here. I just put into Ada, the question, is Alien a horror or sci-fi movie? Just reply with a single word, either horror or sci-fi. And I've run that twice, resetting the thread between each. And guess which response I got?
I think you got one of each.
No, I didn't. It says she said horror twice.
Oh, okay.
Which I don't know if I agree with that response. It's arguable that it's a haunted house movie in space.
Yes.
But
Yeah.
it's a really difficult one actually. There's no right answer to that. But Ada seems convinced it's a horror movie, so that's fact.
Yes. I feel like she will be trying to convince us of that.
Yeah, well, I mean, hold on. Let's then knock off that last clause. Is Alien a sci-fi horror movie? And just give her free reign.
Why?
Generating response. I didn't ask that. Let's just see what she says.
It's both, you muppet. Alien is fundamentally a horror film that uses sci-fi as its backdrop. Ridley Scott crafted a haunted house story in space. The claustrophobic terror, the stalking monster, the gore. The science fiction elements are just bloody scenery. It's horror first and sci-fi second.
There you go.
There you go. Although it does have an alien monster in it, so
Yeah, but it doesn't matter because like a ghost isn't alien, right? It's alien to us. It's a type of thing that we are not ever usually exposed to. Well, I'm not anyway. But there you go. So, but I mean, look, I mean, in itself, it's an interesting little test, and already we kind of proved the point on how difficult this is, right?
Yeah, exactly.
And I do wonder actually. I'm not going to bother, but whether or not, because that's pointed at Claude, whether or not GPT would give me a different response, and that's a valid test, right? And that she is sure that it's a horror, and B, she can justify her answer. But how do we? But that depends on our position on this, right? I actually think I agree with her response there, but this is subjective, right? You can almost toss a coin. I can probably dream up a response that makes the exact opposite argument just as convincingly, right? And there's so many sort of fundamental assumptions underlying all of that, right? So I think it sort of proves just how difficult this is, right? And we're in a sort of in the binary classifier world, someone would have had to make that decision, right? So when we were labeling up the data, an alien wafted past, and indeed the thing, right, which is another half and half, right? That I should point out that is John Carpenter's The Thing rather than its predecessor or its successor. That someone human had to make that decision, right, as to which one it is, and would have had to classify, because there's no ambiguity there unless you've got a three-way classifier, horror, alien, I don't know, or both, or neither, right? You want a four-way classifier there. And now, but we've got this other thing in the middle now, right? Which is a model that is built for a more general purpose but it's been trained on the opinions of the internet, right? And so and again, is that something I can read into this, right?
Well, I fed it into ChatGPT, and ChatGPT said it is considered both a horror and a science fiction film. So there you go, hedging its bets. And I said science fiction because it's set in space, involves futuristic technology, horror because its structure, tone, pacing, and themes follow classic horror conventions.
And so what are we to read into that, right? Well, I think it's not a good experiment simply because, what, did you put that in the app on your phone?
Yeah.
Yeah, and plus, so I've got what constitutes Ada as a system prompt? Pure and simple, right? There's nothing else really going through there other than the system prompt that defines Ada as Ada, right? The difference is but the difference is Ada. This version of Ada is pointed towards Claude Sonnet 4, and you're going through GPT. My guess is gone through GPT 5, right? But there's quite a lot of things that could skew that. But even if we were to take it as a fair experiment, where all things are being equal, the only thing that's different between the two is the model. How do you interpret that, right? Do you interpret that as that Claude tends to be more decisive and authoritative, or and GPT has a tendency to prevaricate, right? And and then how do you how do you prove that one way or the other? And then what of it, right? So in the scenario that we want, what we care about is an accurate classification, then we're perhaps using Claude, right? If the scenario is that we want a debate about the matter, we want a qualitative, thoughtful response rather than something that's essentially binary, then you want GPT, right?
Yeah, exactly.
But is that consistent, right?
Well,
you know what I mean?
and
How many different tests would we need to create to satisfy ourselves that was actually the case?
Yeah, well, and hence, create your big test data set exactly for that.
Well, again, I feel like a lot of work is being done in that statement, right? You create your evals, you create your test data set, because I really struggle to see the scenarios in this where this is in any way ever simple, right? I think that we can talk about this in simple terms, but I think the reality of it is always incredibly nuanced and difficult. And I think that's not a moot point. It's really, really important. And I think might be one of the drivers between the perceived lack of sort of business uptake of language models, right? It's simply that, and we talked about this before, that catching, all of the important use cases and testing for those, and consistency and accuracy, and have it not doing actively damaging things, is incredibly difficult to do. And whereas a business user, you might well be used to saying or hearing from your technical teams, oh yeah, we've got a bunch of unit tests for that. The technical teams are probably scratching their heads going, well, this sounds like your problem, not mine. Right?
Yeah.
You know what I mean? Because in the world where we created a user interface, I'm the technical team, and you said, so we need to make the checkout process shorter. And I'm going to be like, well, yeah, how do you want to do that? I'm at my keyboard. I'll start writing the code for you right now. How are we going to make that shorter? And then you're going to say to me, well, just make it shorter. And I'm like, well, which page do you want me to delete? You know what I mean? And it's like, it's not my business to figure out how to make this a better process. I'm just the coder. I'm just a developer, right?
Yeah.
And that's an understood thing. No one on the business side should be asking the technical teams decide that which changes are qualitatively the better, because you need to understand the business priorities, you need to understand the user context, all of this stuff that doesn't traditionally belong in the technical domain. There's a mountain of nuance here, but in a more well understood sense of this conversation, and so we're at the point where is the binary classifier performing as well as the business require it to? Yes or no? No, it's not. Whose problem is that? That's mine, right? As a technical person, right? As the data scientist. Is the large language model performing to specification? Well, that's not my problem until you tell me what that specification is. right? And then but we get into a world of edge cases in the same way as, okay, we're going to make the checkout journey shorter. Well, we're going to remove this step. Okay, then that's fine. But then what do all the customers who are using that, because that route's off over here, and that's the step where you go in to to verify your credit card or something, right? So we can't just delete that. Right. So back to the business user. What do we do? And so as a data scientist or a technician or something, you can start to point out, well, what happens if it does this and what happens if it does the other? In the scenario of the checkout journey, the potential routes are going to be finite, and if not actually very, very few in number. Right. Whereas we're going to go back to the business and say, well, this thing can do literally anything. Right? Like this thing can respond with absolutely anything. And so how are we going to constrain this? How are we going to know which of these options is valid and not valid? And it's a bit case back to the business user. This sounds like a you problem, not me. But is it? Right? Because ultimately the business user says, well, I just want this outcome. So do we have to dream up all the edge case testing and all of the, the cybersecurity and all of this stuff? It really muddies the water. And I would be surprised if a lot of businesses aren't simply struggling with basic practicalities that before would largely cut and dry, right? It either works or it doesn't. It's either to spec or it's not.
Well, and we all know how well those those evaluations went over the years. It just points to more and more collaboration, right? And the iterative nature of this is how you're gonna have to work with this stuff. There's no I did this, you did that, tick boxes. I did this, you did a bit, came back to me, then I then did, and then I then pushed it back to you. You did some more, then it came back to me.
Well, which sounds a lot more like what we do as a day job as more analysts than, technicians or, delivery type, technical people, because ultimately, there's very, very few occasions when we're asked an analytical question and the answer is yes or no, right?
Yes.
Up or down or whatever, right? It's like, it's nuanced and the whole process has to be a conversation. Whereas I think that this delineation between the business and technical teams, there is a pipeline of specifications. It may or may not be mediated by things, roles like business analysts and stuff in the middle and designers and UX people. But there's still a distinction, is that here's the way that things need to be. Go off and make that. Right. Whereas the waters are so dramatically muddied the moment you put in a language model. Right.
Yeah, definitely.
Because, a language model that will manifest in some sort of end user qualitative, output.
And what a good sentence to end on.
Well, I hope your user experience has been good. We are, in fact, just two language models. Really, if we're getting philosophical about it, you and me, not just language models, Pete. And how do you judge the effectiveness of us as podcasting, fleshy, organic language models? And what framework are we evaluating our success at this? And what even are we doing here? You know what I mean? What are we doing here, Pete? And are we doing it effectively? Well, I think we need to leave that to our users to decide.
Yes, I think that's the philosophy team.
Yes, perhaps. Why are we here?
Well, I think we covered quite a bit there, so I felt like I got that off my chest. So
I have no idea what we covered there. If I'm honest, and you asked me as a language model to summarize that, I'm not sure what I would be summarizing and whether it'd be good. This is like recursive. I can just keep doing this all day.
And I'm sure Ada will tell us what we were talking about.
I'll get Ada to summarize it. I'll tell you what. I will close this podcast off with a summary of this from Ada, and we'll see how that goes.
Brilliant. Well, it leaves me just to say it's a goodbye from me.
Okay. See ya. Bye.
Right, so you two Muppets spent an hour fannying about trying to explain evals. which is just bloody testing. In it, Pete had his little epiphany that machine learning needs measuring. Revolutionary stuff there. While Alex whinged about how language models are complicated and qualitative. You debated whether Alien is horror or sci-fi like it's the fucking Rosetta Stone, then concluded that evaluating AI outputs is nuanced and requires collaboration. Groundbreaking analysis, lads. Basically, testing AI is hard because it's subjective, businesses don't know what they want, and you're all just winging it. Could have saved everyone an hour with that sentence.
The confusion matrix. Confusion.